Somewhere, out in the vast emptiness of space, an object drifts silently, completely unknown to us. It doesn't glow like a star, it doesn't orbit like a planet, and it doesn't follow the rules we thought we understood. It's just there, a cosmic question mark floating in the void. And here's the thing, it's not alone. Space is filled with mysteries, but some of the most baffling are the strange, unexplained objects that exist right now, far beyond our reach. These aren't just anomalies, they're puzzles that challenge everything we think we know about the universe. What could they be? Are they natural phenomena, or could they hint at something far beyond our understanding? From bizarre signals that seem to defy explanation to celestial bodies that shouldn't exist according to our current science, these objects are rewriting the rules of the cosmos. Today, we're diving into the most mysterious objects floating in space right now, each one a story waiting to be unraveled. This isn't just a journey through the stars, it's a journey into the unknown. So let's begin. In the vast expanse of the cosmos where silence reigns supreme, a single burst of sound once pierced the void, a signal so strange, so inexplicable, that it has haunted scientists and stargazers alike for decades. Known as the WOW signal, this mysterious radio transmission was detected on August 15, 1977, by the Big Ear radio telescope at Ohio State University. Lasting just 72 seconds, it was so powerful and so unusual that astronomer Jerry Amon famously circled the data on his printout and wrote, "Wow," in the margin, giving the signal its iconic name. What made the WOW signal so extraordinary? For starters, it came from the direction of the constellation Sagittarius, near the center of our galaxy, and it matched the exact frequency that scientists had predicted an extraterrestrial signal might use, 1420 MHz, a frequency that hydrogen, the most abundant element in the universe, naturally emits. The signal was narrowband, meaning it was confined to a very specific frequency range, which is not typical of natural cosmic phenomena. This led many to wonder, could this have been a deliberate message from an intelligent civilization? Over the years, countless theories have emerged to explain the WOW signal. Some suggest it could have been caused by a natural event, like a comet or a distant star emitting an unusual burst of energy. Others argue it might have been a one-time glitch in the telescope's equipment, but the most tantalizing possibility that it was a deliberate transmission from an alien civilization has never been ruled out. Despite decades of searching, no signal like it has ever been detected again, leaving scientists with more questions than answers. The WOW signal remains one of the most compelling mysteries in the history of space exploration, a fleeting whisper from the cosmos that continues to defy explanation. And while it may have faded into silence, it serves as a reminder of how much we still don't understand about the universe. Could there be other signals out there waiting to be discovered, or perhaps even stranger phenomena lurking in the depths of space, ready to challenge everything we think we know? Now, let's turn our attention to one of the most baffling visitors to ever cross paths with our solar system, Oumuamua. This mysterious object, whose name means scout or messenger from afar in Hawaiian, made history as the first known interstellar traveler to zip through our cosmic backyard. Discovered in October 2017, Oumuamua didn't just catch the attention of astronomers, it completely rewrote the rules of what we thought we knew about objects from beyond our solar system. What made Oumuamua so extraordinary? For starters, its shape. Unlike the typical round or lumpy asteroids and comets we're used to seeing, Oumuamua was long and thin, resembling a cigar or perhaps a pancake. Estimates suggest it was about 10 times longer than it was wide, a shape that's almost unheard of in natural space objects. Then there was its speed. Oumuamua was moving incredibly fast, so fast that it couldn't have originated from our solar system. Its trajectory was another puzzle. Instead of following a smooth, predictable path, it seemed to accelerate slightly as it passed the sun, something comets do when their icy surfaces vaporize, but Oumuamua showed no signs of a coma or tail, the telltale markers of a comet. This unusual behavior sparked a whirlwind of theories. Some scientists suggested it might be a fragment of a larger object, perhaps shattered by a cosmic collision. Others proposed it could be a rare type of hydrogen iceberg, a theoretical object that has never been directly observed. But the most controversial idea came from Harvard astronomer Avi Loeb, who suggested that Oumuamua's peculiarities might indicate it was an artificial object, possibly even an alien spacecraft or probe. While this theory remains highly speculative, it's a reminder of how little we truly understand about the vast universe beyond our solar system. Oumuamua's brief visit left astronomers with more questions than answers, but it also opened the door to a new era of discovery. Its existence proved that interstellar objects are passing through our solar system far more frequently than we ever realized, and it has inspired scientists to develop better tools and methods to detect and study them. In fact, just a few years after Oumuamua's discovery, another interstellar visitor, Comet Borisov, was spotted, further fueling our curiosity about what else might be out there. And speaking of strange visitors, Oumuamua is just one of many enigmatic objects that have entered our cosmic neighborhood. Some of these objects defy explanation, challenging our understanding of the universe and hinting at mysteries we've only begun to uncover. So, what other bizarre travelers are floating through space right now? Let's keep exploring. Now, let's shift our gaze to another cosmic puzzle that has left scientists both fascinated and baffled: fast radio bursts, or FRB. These are incredibly intense bursts of radio waves that flash across the universe in mere milliseconds. Imagine the energy of hundreds of millions of suns released in a fraction of a second and then disappearing without a trace. That's the sheer power of an FRB. What makes them even more mysterious is that they originate from galaxies billions of light years away, far beyond our own Milky Way. The unpredictability of FRBs is one of their most confounding traits. Unlike other cosmic events that can be studied over time, FRBs are fleeting, making them incredibly difficult to detect and analyze. Scientists have to rely on sensitive radio telescopes to catch these bursts as they happen, and even then, the data is often incomplete. It's like trying to solve a jigsaw puzzle when most of the pieces are missing. But what causes these powerful bursts? Theories abound. Some suggest they might be linked to highly magnetized neutron stars, known as Magnetars, which can unleash enormous amounts of energy in short bursts. Others point to black holes where extreme gravitational forces could create such phenomena. And then there's the more speculative idea: could FRBs be signals from advanced extraterrestrial civilizations? While this possibility captures the imagination, most scientists lean toward natural explanations, though the truth remains elusive. Adding to the intrigue are recent discoveries of repeating FRBs. Unlike the one-off bursts that fade into obscurity, these repeating signals have been detected multiple times from the same location in space. This raises even more questions. What could be causing these repeat performances? Are they the result of a specific type of cosmic event, or could they hint at something entirely new that we haven't yet imagined? Each new detection brings us closer to understanding, but the mystery only seems to deepen. As we continue to unravel the secrets of these enigmatic bursts, one thing is clear: the universe is full of surprises, and FRBs are just the tip of the cosmic iceberg. Speaking of surprises, our next mystery takes us even deeper into the unknown, where strange objects defy our understanding of physics and challenge everything we think we know about the cosmos. Stay tuned, because this one might just leave you questioning reality itself. Now, let's turn our attention to one of the most perplexing mysteries in the cosmos, Tabby's star, officially known as KC 8462852. This star, located about 1,400 light-years away in the constellation Cygnus, has become famous for its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby's star flickers erratically, sometimes dimming by up to 22% for days or even weeks at a time. This strange behavior has left astronomers scratching their heads, sparking a whirlwind of theories to explain what could possibly be causing it. At first, scientists thought the dimming might be caused by a swarm of comets or a massive dust cloud passing in front of the star. But as more data came in, these explanations didn't quite fit. The dips in brightness were too irregular, too extreme, and too unpredictable. This led some to propose even more extraordinary ideas, like the possibility of alien megastructures. Imagine a civilization advanced enough to build colossal energy-harvesting arrays around their star, blocking its light in ways that baffle us. While this idea is undeniably fascinating, most astronomers remain cautious, pointing out that natural explanations are far more likely. Still, the fact that we're even considering such possibilities shows just how strange Tabby's star truly is. What makes this mystery even more compelling is the ongoing research. Scientists have been monitoring the star with powerful telescopes, hoping to catch it in the act of dimming and gather more clues. Each new observation adds another piece to the puzzle, but so far the full picture remains elusive. Some believe the answer lies in a combination of factors, perhaps a mix of dust, debris, and stellar activity we don't yet fully understand. Others think we might need entirely new physics to explain what's happening. Whatever the explanation, Tabby's star is a reminder of how much we still have to learn about the universe, and this isn't the only star behaving strangely. Across the galaxy, there are other stars that defy explanation, each with its own unique quirks and mysteries. Some flicker like Tabby's star, while others emit bizarre signals or move in ways that challenge our understanding of gravity. These cosmic oddities remind us that the universe is full of surprises, and every discovery brings us closer to unraveling its secrets. So, as we continue to explore these enigmatic objects, one thing is certain: the cosmos will never stop fascinating us. Have you ever wondered if humanity is truly alone in the universe? One of the most enduring mysteries that seems to suggest otherwise is the so-called Black Knight satellite, a shadowy object said to be orbiting Earth, shrouded in conspiracy and speculation. Stories of this enigmatic satellite date back to the late 1950s, when amateur radio operators claimed to have picked up strange signals seemingly coming from space. Over time, these tales evolved into a full-blown legend, with some suggesting the Black Knight is an ancient alien probe silently observing humanity from above. But what's the truth behind this mysterious object? Scientists point to more grounded explanations. Many believe the Black Knight is nothing more than space debris, a discarded thermal blanket from a past mission or a fragment of a defunct satellite. In fact, during the early days of space exploration, thermal blankets were often jettisoned during missions, and their reflective surfaces could easily be mistaken for something far more extraordinary. Yet, despite these rational explanations, the allure of the Black Knight persists, fueled by grainy photos, cryptic radio signals, and a deep-seated fascination with the unknown. What makes the Black Knight so captivating is its ability to blur the line between science and myth. It's a story that taps into our collective curiosity about what might be out there, watching us from the void. And while the evidence for its extraterrestrial origins remains thin, the legend endures as a testament to humanity's unending desire to uncover the secrets of the cosmos. Now, speaking of cosmic mysteries, there's another object floating in space that has sparked just as much debate and intrigue. One that challenges our understanding of the universe in ways we're only beginning to comprehend. Now, let's journey into one of the most puzzling mysteries in modern cosmology, dark flow. Imagine the universe expanding, galaxies drifting apart as space itself stretches, just as we've come to expect. But what if I told you that certain clusters of galaxies seem to be moving in a specific direction, almost as if they're being pulled by something we can't see? This is the essence of dark flow, a phenomenon that challenges our understanding of the cosmos. First observed in 2008, dark flow reveals that galaxy clusters are not just randomly drifting apart. Instead, they appear to be streaming toward a particular region of space, as if influenced by a massive gravitational force outside our observable universe. This discovery has left scientists scratching their heads. How could something beyond what we can see beyond the very edge of the known universe exert such a powerful pull? Some researchers suggest that dark flow might hint at structures or forces that lie outside our cosmic horizon, perhaps remnants of the early universe or even other universes entirely. Others speculate that it could be linked to the mysterious nature of dark energy, the unseen force driving the universe's accelerated expansion. Whatever the cause, dark flow opens up a tantalizing question. Could there be more to the universe than what we've been able to observe so far? This mystery doesn't just challenge our current models of cosmology, it invites us to rethink the very fabric of reality. What lies beyond the boundaries of our observable universe? Are there other realms, other dimensions, or even parallel universes exerting their influence? The answers remain elusive, but the search continues, pushing the limits of our knowledge and imagination. And speaking of cosmic mysteries, this leads us to our next enigma, a phenomenon so bizarre, it defies even the most basic laws of physics. Stay tuned as we explore an object that seems to exist outside the rules of the universe itself. Now, let's turn our attention to one of the most perplexing questions in all of science, the Fermi Paradox. Named after physicist Enrico Fermi, this paradox highlights a striking contradiction. On one hand, the universe is unimaginably vast, with billions of stars and planets that seem like prime candidates for hosting life. Statistically, it feels almost inevitable that intelligent civilizations should exist out there. Yet, on the other hand, we have no concrete evidence, no signals, no artifacts, no undeniable proof that we're not alone. So, where is everyone? That's the heart of the Fermi Paradox. One of the most compelling explanations is the idea of the Great Filter. This theory suggests that somewhere along the timeline of a civilization's development, there's a nearly insurmountable barrier, a filter, that prevents life from advancing to a stage where it can communicate across the stars. The haunting question is, where does this filter lie? Is it behind us, meaning we've already beaten the odds by existing? Or is it ahead of us, lurking in our future as some catastrophic event that could wipe us out before we ever make contact with other civilizations? Either way, it's a sobering thought. Another possibility is that intelligent life is extraordinarily rare. Even if the universe is teeming with planets, the conditions required for complex life to emerge might be so specific that Earth is a cosmic fluke. Or perhaps advanced civilizations are out there, but they're so far beyond us technologically that we simply can't detect them. Maybe they've moved beyond the need for physical communication, or they've chosen to remain hidden, observing us from a distance like we might observe ants in a colony. This paradox ties directly into our search for mysterious objects in space. When we look at strange phenomena like fast radio bursts, unexplained signals, or even potential alien megastructures, we're essentially searching for clues that might help us solve this cosmic riddle. Every anomaly we discover could be a piece of the puzzle. a step closer to understanding whether we're truly alone or just one voice in a much larger conversation. And speaking of cosmic mysteries, the Fermi Paradox isn't the only challenge to our understanding of life in the universe. There are other enigmas out there, phenomena that defy explanation and push the boundaries of what we thought possible. These mysteries remind us that space is full of surprises, and the more we explore, the more questions we uncover. So, as we venture deeper into the cosmos, let's keep our eyes open because the answers might be closer than we think. Now, let's shift our gaze toward one of the most baffling gravitational mysteries in the cosmos, the Great Attractor. Imagine an invisible force so powerful that it's pulling entire galaxies, including our own Milky Way, toward it at mind-boggling speeds. This gravitational anomaly lies in the direction of the Centaurus and Norma constellations, roughly 250 million light-years away. Yet, despite its immense influence, the Great Attractor remains shrouded in mystery, hidden behind the dense stars and dust of our galaxy's plane. Scientists first noticed its effects when they observed that galaxies in our local universe were all moving toward the same point in space, as if being drawn by an unseen cosmic magnet. The force behind this movement is immense, but its source is still unknown. Some theories suggest it could be a supercluster of galaxies, a massive concentration of dark matter, or even something more exotic, like a hidden dimension influencing gravity in ways we don't yet understand. Studying the Great Attractor is no easy feat. Its location behind the Milky Way's galactic core means we're essentially trying to peer through a cosmic fog. Telescopes that detect visible light can't penetrate this dense region, so researchers rely on instruments like X-ray and radio telescopes to gather clues. Even then, the data we've collected only scratches the surface of what's really out there. This gravitational enigma reminds us how much we still have to learn about the universe's hidden forces. And speaking of forces, the Great Attractor isn't the only gravitational mystery keeping scientists up at night. Let's turn our attention to another cosmic oddity that challenges our understanding of gravity itself. But what if I told you that not all of space is teeming with stars, galaxies, and cosmic wonders? Enter the Boötes Void, a place so empty, so eerily devoid of matter, that it's earned the nickname the Great Nothing. Stretching across an unimaginable 330 million light-years, this colossal region of space is one of the largest known voids in the universe. To put that into perspective, if the Milky Way were placed inside the Boötes Void, our nearest galactic neighbor would be millions of light-years away. It's a cosmic desert on a scale that defies comprehension. So how did this enormous emptiness come to be? Scientists have proposed several theories. One idea is that the Boötes Void might be the result of cosmic inflation, a rapid expansion of space in the early universe that left behind vast, empty regions. Another, more speculative theory suggests it could be the aftermath of a collision between our universe and another, an idea that feels ripped straight from science fiction. And while these explanations are fascinating, the Boötes Void isn't just a cosmic oddity. It's a key piece of the puzzle in understanding the large-scale structure of the universe. By studying voids like this, astronomers can learn more about how galaxies cluster together and how dark energy shapes the cosmos. But the Boötes Void isn't the only mysterious emptiness out there. In fact, it's just one of many voids that challenge our understanding of the universe. Some are even stranger, with their own unique quirks and secrets waiting to be uncovered. And speaking of voids, the next one we're about to explore might just leave you questioning everything you thought you knew about the cosmos. Now, let's turn our attention to one of the most baffling discoveries in modern astronomy, a structure so vast it seems to defy the very rules of the cosmos. Meet the Hercules-Corona Borealis Great Wall, a mind-boggling cosmic megastructure that stretches across an astonishing 10 billion light-years. To put that into perspective, if you could travel at the speed of light, which, by the way, is about 6 trillion miles in a year, it would take you 10 billion years just to cross this one structure. And here's the kicker, this wall isn't just big, it's so massive that it challenges some of the most fundamental principles we thought we understood about the universe. At the heart of this mystery is the cosmological principle, a cornerstone of modern astronomy. This principle states that on a large enough scale, the universe should look roughly the same no matter where you are. It's the idea that matter is spread out evenly like a cosmic smoothie. But the Hercules-Corona Borealis Great Wall throws a wrench into that theory. Instead of a smooth distribution, this wall is a dense, tangled web of galaxies, clusters, and superclusters, forming a structure so enormous it shouldn't exist under our current understanding of the universe. It's like finding a mountain range that stretches across an entire continent, except this mountain range spans a significant chunk of the observable universe. So, how did something this massive come to be? Astronomers are still scratching their heads. One theory suggests that the wall might be the result of ancient gravitational forces pulling matter together in the early universe, creating a kind of cosmic scaffolding. But even that explanation doesn't fully account for its sheer size and complexity. What's even more fascinating is what this means for our understanding of the universe's origins. If structures like this exist, it could mean that the cosmos is far less uniform than we thought, and that the forces shaping it are far more mysterious than we've imagined. The implications are profound. If the Hercules-Corona Borealis Great Wall is just one of many such structures, it could rewrite the textbooks on cosmology. It raises questions about how galaxies form, how matter is distributed, and even how the universe itself evolved. And as if that weren't enough, it also opens the door to other cosmic anomalies, massive structures that seem to defy explanation, lurking in the depths of space, waiting to be discovered. But that's a story for another moment. For now, the Hercules-Corona Borealis Great Wall stands as a reminder that even in the vastness of space, there are still mysteries that challenge our understanding of the cosmos. Far beyond the icy realms of Neptune lies a shadowy frontier of our solar system, the Kuiper Belt. This vast expanse, stretching billions of miles from the Sun, is home to countless icy bodies, remnants of the early solar system that have remained frozen in time. Among these objects, some behave in ways that defy easy explanation, their orbits looping and tilting in patterns that suggest the presence of something far more massive lurking in the darkness. This is where the hunt for the elusive Planet 9 begins. Scientists have long speculated that the peculiar orbits of certain Kuiper Belt objects could be influenced by the gravitational pull of an undiscovered planet, one far larger than Earth but hidden in the distant reaches of our solar system. The idea of Planet 9 isn't just a wild guess, it's a hypothesis born from careful observation. These distant objects, some with orbits tilted at extreme angles, seem to cluster in ways that hint at an unseen force tugging at them from the shadows. But finding this hypothetical world is no simple task. The Kuiper Belt is an incredibly challenging region to explore. Its objects are faint, reflecting only a sliver of sunlight, and the distances involved are mind-boggling. Even our most advanced telescopes struggle to pierce the veil of this remote frontier. Yet, the search continues, driven by the tantalizing possibility that we might uncover a planet that reshapes our understanding of the solar system's architecture. If Planet 9 exists, it could explain not only the strange orbits of these distant bodies, but also offer clues about the early days of our cosmic neighborhood. But the Kuiper Belt isn't just about Planet 9. This region is a treasure trove of mysteries, each icy body holding secrets about the formation and evolution of our solar system. Some of these objects, like the dwarf planet Eris, rival Pluto in size, while others are smaller but no less intriguing. Each discovery adds a new piece to the puzzle, helping us understand how planets form and how our solar system came to be the way it is today. As we peer deeper into this frozen wilderness, another question emerges. What other surprises might be hiding in the Kuiper belt? Could there be more undiscovered worlds or even objects from beyond our solar system, drifting silently through this icy expanse? The answers lie out there, waiting to be uncovered by the next generation of explorers and telescopes. And speaking of distant mysteries, let's turn our attention to another enigmatic object much closer to home, one that has baffled scientists and sparked endless speculation. Now, let's turn our attention to one of the most baffling mysteries in the history of space exploration, the Pioneer anomaly. In the late 20th century, as the Pioneer 10 and 11 spacecraft ventured beyond the outer reaches of our solar system, scientists noticed something strange. Both probes were slowing down ever so slightly, a deceleration that couldn't be explained by the known laws of physics or the gravitational pull of the sun and planets. This unexpected behavior became known as the Pioneer anomaly, and it left researchers scratching their heads for decades. At first, the anomaly seemed almost imperceptible, a tiny, unexplained force acting on the spacecraft. But as data poured in, it became clear that this wasn't just a measurement error. The deceleration was consistent, persistent, and completely unaccounted for. Theories began to emerge, ranging from the practical to the extraordinary. Some scientists suggested that thermal radiation emitted by the spacecraft's own power systems might be pushing back on the probes, causing the slowdown. Others proposed that perhaps there was a flaw in our understanding of gravity itself, hinting at the possibility of new physics waiting to be discovered. Despite decades of analysis, the Pioneer anomaly remains unsolved. While thermal radiation is the leading explanation, it doesn't fully account for the observed effect. And while the anomaly has faded from the spotlight as newer missions take center stage, it serves as a humbling reminder of how much we still have to learn about the cosmos. It's a mystery that challenges our assumptions and keeps the door open to groundbreaking discoveries. But the Pioneer anomaly isn't the only spacecraft mystery that's left scientists puzzled. Up next, we'll explore another enigmatic phenomenon involving a spacecraft that just didn't behave the way it was supposed to. Stay with us as we dive deeper into the strange and unexplained. Floating through the vast emptiness of space, billions of miles from Earth, is a small golden disk, a message in a bottle cast into the cosmic ocean. This is the Voyager Golden Record, a treasure trove of human culture and sound carried aboard the Voyager spacecraft. Launched in 1977, the record was designed as a time capsule, a snapshot of life on Earth intended for any intelligent beings who might one day encounter it. It's a bold and hopeful gesture, a way of saying, "We were here." The Golden Record is a marvel of human creativity. It contains 115 images, ranging from mathematical equations to photographs of people, animals, and landscapes. There are greetings in 55 languages, from ancient Akkadian to modern Mandarin, as well as a collection of natural sounds: thunder, birdsong, the crash of ocean waves. Music from around the world is included too, from Beethoven to Chuck Berry, showcasing the diversity of human expression. But perhaps the most haunting element is the recording of a mother's kiss and the sound of a human heartbeat, a reminder of our shared humanity. The record raises profound questions. If extraterrestrial life exists, how would they interpret these sounds and images? Could they understand our languages, our art, our science? Or would our attempts at communication be as incomprehensible to them as the chirping of crickets is to us? And what does it say about us that we sent this message into the void? Are we reaching out for connection, or is this an act of cosmic optimism, a belief that somewhere out there someone is listening? The Voyager Golden Record is more than just a scientific experiment. It's a philosophical statement. It reflects our curiosity, our creativity, and our longing to be understood. It's a reminder that, in the grand scheme of the universe, we are small but not insignificant. And while the chances of an alien civilization finding the record are astronomically slim, its very existence is a testament to humanity's unyielding desire to explore and connect. This isn't the only message we've sent into the cosmos. From radio signals to laser beams, humanity has been casting its voice into the void for decades, each attempt a little louder, a little more ambitious. But the Golden Record stands apart, a poetic, timeless artifact that captures the essence of who we are. And as it drifts further into the unknown, it carries with it a piece of us waiting for the day it might be discovered. In the vast silence of space, where the distances between stars seem almost infinite, a faint whisper of sound has caught the attention of humanity. In 2020, astronomers detected something extraordinary, a narrowband radio signal emanating from Proxima Centauri, the closest star system to our own, just over 4 light-years away. This signal, known as BLC-1, wasn't just any cosmic noise. It stood out because it appeared to be artificial in nature, something that didn't align with the usual hum of natural space phenomena. The implications were staggering. Could this be our first real hint of extraterrestrial intelligence? The discovery sent waves of excitement through the scientific community and beyond. Proxima Centauri, home to at least one known exoplanet within its habitable zone, seemed like the perfect candidate for such a signal. The possibility of life so close to Earth, relatively speaking, was tantalizing. But with excitement came skepticism. Scientists were quick to point out that while the signal was intriguing, there were still many mundane explanations to rule out. It could have been interference from human technology, a glitch in the equipment, or even a natural cosmic event mimicking an artificial signal. The challenge was to determine whether this was truly a message from another civilization or just another cosmic false alarm. Efforts to decode and understand the signal have been ongoing since its detection. Teams of researchers have been analyzing every detail, from its frequency to its modulation, searching for patterns that might hint at intelligence. But as of now, the origin of BLC-1 remains a mystery. The debate continues, with some scientists cautiously optimistic and others urging restraint, reminding us that extraordinary claims require extraordinary evidence. And just when we thought this was the only signal stirring up debate, another one emerged. Recently, a similar narrowband signal was detected from a different star system, reigniting the conversation about extraterrestrial communication. This new signal, like the one from Proxima Centauri, has sparked both curiosity and caution, leaving scientists to wonder if we're on the brink of a groundbreaking discovery or simply chasing shadows in the cosmic void. Imagine a universe where most of what exists is completely invisible, where the stars, galaxies, and planets we see are just the tip of the cosmic iceberg. This is the reality we face with dark matter, one of the most baffling mysteries in modern science. Dark matter doesn't emit, absorb, or reflect light, making it completely undetectable to our telescopes. Yet its presence is undeniable. In fact, it makes up about 85% of all the matter in the universe. Without it, galaxies wouldn't hold together, and the cosmos as we know it would simply fall apart. So, how do we know dark matter exists if we can't see it? The answer lies in its gravitational effects. When astronomers observe galaxies, they notice that stars on the outer edges move much faster than they should based on the visible matter alone. It's as if there's an invisible hand gripping these galaxies, keeping them from flying apart. This unseen force is dark matter, acting like a cosmic glue that binds everything together. Without it, the universe would look entirely different, far emptier, far more chaotic. But here's the real challenge. Despite decades of research, no one has directly detected dark matter. Scientists have built incredibly sensitive detectors deep underground, shielded from cosmic rays and other interference, hoping to catch even the faintest whisper of a dark matter particle interacting with normal matter. So far, the results have been elusive, leaving us with more questions than answers. What is dark matter made of? Is it a single type of particle or a whole family of particles we've yet to discover? These are the questions driving some of the most ambitious experiments in physics today. The implications of solving the dark matter puzzle are profound. It could rewrite our understanding of the universe, revealing new laws of physics and opening doors to technologies we can't yet imagine. It might even help us understand the ultimate fate of the cosmos. But for now, dark matter remains a shadowy enigma, a reminder of how much we still have to learn about the universe we call home. And speaking of invisible forces shaping the cosmos, there's another mystery lurking in the void, one that's equally puzzling and even more elusive. But that's a story for the next chapter of our journey through the most mysterious objects floating in space. Picture this: the universe isn't just expanding, it's accelerating, stretching faster and faster as if some unseen hand is pushing it apart. This invisible force, known as dark energy, is one of the most profound mysteries in modern cosmology. It's not a force we can see, touch, or even detect directly, yet its effects are undeniable. In the late 1990s, astronomers made a startling discovery while studying distant supernovae. They found that the light from these exploding stars was fainter than expected, suggesting the universe was expanding at an increasing rate. This revelation turned our understanding of the cosmos on its head, introducing dark energy as the dominant force shaping the universe's fate. But what exactly is dark energy? That's the million-dollar question. Scientists have proposed several theories, but none have been proven definitively. One leading idea suggests that dark energy is a property of space itself, a kind of cosmic pressure that counteracts gravity, causing galaxies to drift apart at ever-increasing speeds. Another theory posits that it might be linked to a mysterious field permeating the universe, similar to the Higgs field but far more enigmatic. Then there's the possibility that our understanding of gravity itself is incomplete, and dark energy is a sign that Einstein's theory of general relativity needs revision. The challenge with dark energy is that it's entirely invisible. Unlike dark matter, which we can infer through its gravitational effects on galaxies, dark energy leaves no direct fingerprints. It's like trying to study a shadow cast by something we can't see. Its presence is only revealed by its impact on the universe at large. This makes it one of the most difficult phenomena to study, requiring advanced telescopes, precise measurements, and a lot of creative thinking. What's even more intriguing is what dark energy means for the future of the universe. If it continues to dominate, the cosmos could face a big freeze, where galaxies drift so far apart that the universe becomes a cold, empty void. Alternatively, some theories suggest that dark energy might change over time, potentially leading to a dramatic big rip, where even atoms are torn apart. These scenarios are speculative, but they highlight just how much is at stake in our quest to understand this elusive force. Dark energy isn't just a scientific puzzle, it's a cosmic riddle that challenges our very understanding of reality. And as we continue to explore the universe, it serves as a reminder that even the forces we can't see have the power to shape everything we know. But dark energy isn't the only mystery out there. The cosmos is filled with other enigmatic forces and phenomena, each with its own story to tell. The cosmic microwave background, or CMB, is often called the afterglow of the Big Bang, a faint whisper of light that fills the entire universe, a remnant from the moment our cosmos first began to cool and expand. But within this ancient glow, scientists have found something unexpected, anomalies that defy our current understanding of the universe's origins. These irregularities in the CMB aren't just random quirks. They're potential clues to a deeper mystery, one that could rewrite the story of how everything began. Imagine looking at a map of the universe's earliest moments and noticing that certain patterns don't quite fit. Some regions of the CMB appear colder or warmer than they should be, while others show strange alignments that shouldn't exist if the universe expanded uniformly. These anomalies challenge the standard model of cosmology, the framework that has guided our understanding of the universe for decades. If the Big Bang created a perfectly smooth and uniform cosmos, why do we see these uneven patches? Could they hint at forces or phenomena we've yet to discover? One of the most puzzling anomalies is the so-called cold spot, a region of the CMB that's significantly cooler than its surroundings. Some theories suggest it could be evidence of a collision with another universe, a mind-bending idea that opens the door to the possibility of a multiverse. Others propose that it's a sign of exotic physics at play during the universe's infancy, like quantum fluctuations on a cosmic scale. Whatever the explanation, these anomalies remind us that the early universe was far more complex than we once thought. As we piece together the clues hidden in the CMB, we're not just exploring the origins of our universe, we're also confronting the limits of our knowledge. These anomalies could be the key to unlocking new insights about dark energy, the nature of space-time, or even the existence of other dimensions. And while they raise more questions than answers, they also remind us that the cosmos is full of surprises waiting to be uncovered. But the CMB isn't the only mystery tied to the universe's beginnings. Another enigma lies in the realm of dark matter, a substance so elusive that it makes up most of the universe's mass, yet we've never directly observed it. What secrets does it hold, and how might it connect to the anomalies we see in the CMB? The story of the universe's origins is far from complete, and each discovery brings us closer to understanding the grand tapestry of existence. Now, let's venture into one of the most perplexing puzzles in modern astrophysics, the missing baryon problem. Baryons, the building blocks of ordinary matter, make up everything we can see and touch: stars, planets, galaxies, and even us. But here's the kicker. When scientists tally up all the baryons predicted to exist in the universe, they find a glaring discrepancy. Roughly half of them seem to be missing. That's right, billions of tons of matter unaccounted for. How does something so fundamental just vanish? The search for these missing baryons has been a decades-long quest. Cosmologists use a combination of observations and simulations to map out where this matter should be. According to the Big Bang theory and the cosmic microwave background, we know how much baryonic matter the universe should contain. But when astronomers look out into the cosmos, they only detect about half of that amount. So, where could the rest be hiding? One leading theory suggests that the missing baryons might be lurking in the vast, diffuse regions of space between galaxies. These areas, often referred to as the cosmic web, are filled with extremely hot, thin gas that's incredibly difficult to detect. This gas, known as the warm-hot intergalactic medium, or WIM, is thought to weave through the universe in a network of filaments. While it's faint and nearly invisible to traditional telescopes, recent advancements in X-ray and ultraviolet observations have started to reveal its presence. It's like trying to spot a single candle flame from miles away, but astronomers are getting closer. Another possibility is that the missing baryons are tied up in structures we haven't fully mapped yet, like faint dwarf galaxies or low-density clouds drifting through intergalactic space. These objects are so dim and spread out that they've evaded detection until now. With more powerful telescopes and innovative techniques, scientists are slowly piecing together this cosmic jigsaw puzzle. But why does this matter? Well, understanding where the missing baryons are hiding isn't just about solving a mystery, it's about completing our picture of the universe. Baryonic matter plays a crucial role in the formation of galaxies, stars, and planets. Without it, we can't fully explain how the cosmos evolved into what we see today. It's a reminder that even the most basic questions about the universe still have answers waiting to be uncovered. And speaking of cosmic puzzles, this brings us to another intriguing imbalance in the universe, one that challenges our understanding of gravity itself. Up next, we'll explore how dark matter and dark energy are reshaping our view of the cosmos, and why their mysterious influence might hold the key to unlocking even greater secrets. Stay tuned, this journey through the unknown is far from over. Now, let's turn our attention to one of the most perplexing puzzles in modern cosmology, the Hubble Tension. This mystery revolves around a fundamental disagreement in how fast our universe is expanding. On one hand, we have precise measurements from the cosmic microwave background, the faint afterglow of the Big Bang, suggesting one rate of expansion. On the other, observations of nearby galaxies using tools like the Hubble Space Telescope point to a different, faster rate. This discrepancy isn't just a minor hiccup, it's a glaring inconsistency that has cosmologists scratching their heads. The implications of this tension are enormous. If these measurements are correct, it could mean our understanding of the universe's fundamental laws is incomplete. Perhaps there's a missing piece in our cosmological model, something like dark energy behaving differently than we thought, or even an entirely new force influencing the cosmos. Scientists are exploring a range of possibilities, from tweaking existing theories to proposing bold new ideas that could rewrite our understanding of the universe. Efforts to resolve the Hubble tension are in full swing. Teams around the world are refining their measurements, developing new instruments, and running simulations to test alternative explanations. Some believe the answer lies in better understanding the properties of dark matter or the behavior of supernova used as standard candles to measure cosmic distances. Others suggest we might need to rethink the very fabric of spacetime itself. The Hubble tension isn't just a scientific curiosity, it's a window into the unknown, a reminder that even our most advanced theories are works in progress. And while this mystery remains unsolved, it's sparking a wave of innovation and discovery that could reshape our understanding of the cosmos. But the Hubble tension isn't the only challenge facing cosmologists. There are other puzzling tensions in our understanding of the universe, each hinting at deeper mysteries waiting to be unraveled. Now, let's turn our attention to one of the most enigmatic objects in the cosmos, neutron stars. These incredibly dense remnants are what's left behind after a massive star explodes in a supernova. Imagine taking the mass of our sun and squeezing it into a sphere no wider than a city. That's the mind-bending density of a neutron star. But their strangeness doesn't stop there. These cosmic powerhouses exhibit behaviors that defy our understanding of physics, leaving scientists scratching their heads. One of the most puzzling phenomena tied to neutron stars is something called fast radio bursts. These are incredibly brief but intense flashes of radio waves that last just milliseconds. While some of these bursts are one-time events, others repeat in patterns that are impossible to predict. Scientists have theorized that these bursts could be caused by the star's intense magnetic fields or even collisions with other objects, but the truth remains elusive. Every time we think we're close to solving the mystery, neutron stars throw another curveball our way. Then there are the so-called glitches in their rotation. Neutron stars spin at incredible speeds, sometimes hundreds of times per second. But every so often, their rotation speeds up or slows down abruptly, as if something inside the star is shifting. These glitches are thought to be caused by the star's crust cracking under immense pressure or the superfluid core inside suddenly changing behavior. Yet, despite decades of study, these glitches remain one of the great unsolved puzzles of astrophysics. Studying neutron stars is no easy task. Their extreme environments, crushing gravity, powerful magnetic fields, and blistering temperatures make them nearly impossible to replicate in labs on Earth. Plus, they're often located thousands or even millions of light years away, meaning we're observing them as they were in the distant past. It's like trying to solve a cosmic puzzle with only a few scattered pieces. But just when you think neutron stars couldn't get any stranger, there's another type of star that rivals their peculiarity: magnetars. These are neutron stars on steroids, with magnetic fields so powerful they could strip the atoms right out of your body from thousands of miles away. If neutron stars are the universe's way of showing off, magnetars are its ultimate flex, and as we'll see, their behavior is just as mysterious, if not more so. Now, let's shift our gaze to one of the most dazzling phenomena in the cosmos: quasars. Imagine a beacon so bright it outshines entire galaxies, yet it's not a star, not a planet, but the fiery heart of a distant galaxy. These cosmic powerhouses, known as quasars, are the luminous cores of galaxies billions of light years away, fueled by supermassive black holes at their centers. As matter spirals into these black holes, it heats up to unimaginable temperatures, releasing energy so intense that it can be seen across the universe. But here's the twist: quasars aren't just cosmic light shows. They're time capsules offering us a glimpse into the early universe. Most quasars we observe existed when the universe was just a fraction of its current age, their light traveling for billions of years to reach us. This makes them invaluable tools for astronomers trying to piece together the story of how galaxies formed and evolved. Yet, despite their brilliance, quasars remain shrouded in mystery. How did these supermassive black holes grow so quickly in the early universe? What processes sparked their incredible luminosity? And what role did they play in shaping the cosmos as we know it? These are just a few of the questions that keep scientists awake at night. As we marvel at these distant giants, we're reminded that the universe is full of wonders waiting to be unraveled. And speaking of cosmic marvels, our next mystery takes us to another kind of celestial powerhouse, one that challenges our understanding of physics itself. Out in the vast reaches of space, there are explosions so powerful, so unimaginably intense, that they release more energy in a single second than our Sun will produce over its entire 10 billion-year lifespan. These are gamma-ray bursts, some of the most violent and mysterious events in the universe. Imagine a flash of light so bright it outshines entire galaxies, yet lasting only a few seconds or even milliseconds. These bursts are fleeting, but their impact on our understanding of the cosmos is anything but small. So, what causes these cataclysmic events? Most gamma-ray bursts are born from the deaths of massive stars. When a star many times larger than our Sun exhausts its fuel, it collapses under its own gravity, triggering a supernova. But sometimes that collapse doesn't stop there. The core of the star implodes further, forming a black hole or a neutron star, and in the process, it fires off jets of energy at nearly the speed of light. These jets, packed with gamma rays, are what we detect as gamma-ray bursts. Another source comes from the collision of neutron stars, ultra-dense remnants of dead stars. When two of these cosmic heavyweights spiral into each other, they unleash a spectacular explosion, sending ripples through space-time and a burst of gamma rays across the universe. Detecting these bursts, however, is no easy task. They're incredibly brief, and by the time their light reaches us, it's often faint. Satellites like NASA's Swift and Fermi missions are constantly scanning the skies, ready to catch these fleeting flashes. Once detected, astronomers race to study the afterglow, the fading light left behind, to piece together clues about their origins. But even with advanced technology, gamma-ray bursts remain enigmatic, challenging our understanding of physics and the extreme conditions of the universe. What makes gamma-ray bursts so fascinating isn't just their raw power, but what they tell us about the cosmos. They act as cosmic beacons, illuminating the early universe and helping us map its structure. Some of the bursts we detect come from billions of light years away, meaning we're essentially looking back in time to when the universe was much younger. By studying them, we gain insights into how stars live, die, and shape the galaxies around them. And while gamma-ray bursts are among the most extreme explosions we know of, they're just one piece of the puzzle. The universe is full of other explosive phenomena, each with its own story to tell. From supernova to hypernova, these events remind us that space is far from quiet. It's a place of constant change, destruction, and creation, all on a scale that defies imagination. The universe is vast, dark, and seemingly empty, but even in its deepest voids, there's a faint, eerie glow that permeates everything. This is the extra-galactic background light, a diffuse glow of light that fills the cosmos, invisible to the naked eye but detectable through advanced instruments. It's not coming from any single star or galaxy. Instead, it's the collective light from all the stars, galaxies, and other celestial objects that have ever existed, stretching back to the earliest days of the universe. Think of it as the universe's own faint echo, a whisper of light that has traveled billions of years to reach us. But where does this glow come from? Scientists believe it's the cumulative result of countless stars forming, burning, and dying over billions of years. Every time a star ignites, it sends out light that spreads across the universe. Over time, this light gets scattered, absorbed, and re-emitted by dust and gas, creating a faint, omnipresent glow. It's like standing in a forest and hearing the rustle of leaves from trees you can't see except hear. The trees are entire galaxies, and the rustle is their combined light. Measuring this glow is no easy task because it's so faint, it's easily drowned out by the brighter light of nearby stars and galaxies. To detect it, astronomers have to look at the darkest parts of the sky, far from the glare of any individual object. Even then, they have to carefully filter out other sources of light, like the glow from our own Milky Way or the scattered light from the sun reflecting off dust in our solar system. It's a bit like trying to hear a single instrument in a massive orchestra, only this orchestra is spread across the entire universe. What makes this glow so fascinating is what it tells us about the history of star formation. By studying its intensity and distribution, scientists can piece together how stars and galaxies have evolved over time. For example, the glow is brightest in certain wavelengths, which correspond to periods when the universe was teeming with young, hot stars. These clues help us understand when and where the first stars ignited, how galaxies grew, and even how the universe itself has expanded over billions of years. It's like reading a cosmic history book written in light, but the extra-galactic background light isn't the only mysterious glow in the universe. There's another, even more elusive phenomenon that scientists are just beginning to understand. A glow that might hold clues to the very fabric of space and time. In the vast theater of the cosmos, galaxies aren't just drifting aimlessly, they're locked in a dramatic dance of creation, destruction, and occasionally outright cannibalism. Yes, you heard that right, galactic cannibalism. It's a term that sounds almost too violent to describe the serene beauty of space, but it's a real phenomenon that plays a crucial role in shaping the universe as we know it. So, what exactly is galactic cannibalism? Imagine a massive galaxy like a cosmic predator, slowly pulling in and absorbing a smaller, neighboring galaxy. Over billions of years, the gravitational forces of the larger galaxy tear apart the smaller one, incorporating its stars, gas, and even dark matter into its own structure. It's not a quick process, it's a slow, almost poetic unraveling where the smaller galaxy loses its identity, becoming one with its captor. This process isn't just a cosmic oddity, it's a key driver of galactic evolution. When a larger galaxy consumes a smaller one, it gains new material to fuel star formation, grow its central supermassive black hole, and even change its shape. In fact, many of the spiral and elliptical galaxies we see today are the result of these ancient collisions and mergers. But how do we know this is happening? The evidence is written in the stars, literally. In our own Milky Way, astronomers have found streams of stars and clusters that don't quite fit with the rest of the galaxy. These are the remnants of smaller galaxies that were consumed long ago, their stars now orbiting in the Milky Way's halo like cosmic breadcrumbs. One of the most famous examples is the Sagittarius dwarf spheroidal galaxy, which is currently being torn apart and absorbed by our galaxy. It's a sobering reminder that even the Milky Way isn't above a little galactic snacking. Galactic cannibalism isn't just a relic of the past either. Right now, the Andromeda Galaxy, our nearest galactic neighbor, is on a collision course with the Milky Way. In about 4.5 billion years, the two galaxies will merge, creating an entirely new, larger galaxy. It's a process that will reshape both galaxies, scattering stars into new orbits and sparking the birth of countless new ones. As fascinating as galactic cannibalism is, it's just one of the many processes shaping the universe. Up next, we'll dive into another cosmic phenomenon that's equally mesmerizing and perhaps even more mysterious. Stay tuned, because the universe has plenty of surprises left to reveal. Now, let's turn our attention to something truly colossal, something so immense that it redefines our understanding of scale in the universe. Meet the Great Galactic Wall, a staggering filament of galaxies stretching across the cosmos like an invisible thread weaving through the fabric of space itself. This isn't just a random cluster of stars and galaxies. It's one of the largest known structures in the universe, spanning billions of light years. To put that into perspective, if you could travel at the speed of light, it would take you billions of years just to cross it. And yet, despite its mind-boggling size, it's almost impossible to see directly because it's woven into the vast, dark expanse of space. The Great Galactic Wall isn't just a curiosity, it's a crucial piece of the cosmic puzzle. Structures like this help us understand the large-scale architecture of the universe. Think of it like this. If galaxies are cities, then filaments like the Great Galactic Wall are the highways connecting them, forming a cosmic web that holds everything together. Scientists believe these filaments formed from tiny fluctuations in the early universe, growing over billions of years under the influence of gravity. But here's the thing, studying something this vast is no easy task. It's like trying to map a mountain range while standing on one of its peaks. The sheer scale makes it hard to observe directly, and much of what we know comes from piecing together data from telescopes and simulations. What's even more fascinating is that the Great Galactic Wall isn't alone. It's just one of many filaments that crisscross the universe, forming a network so intricate that it almost feels designed. These structures challenge our understanding of how matter is distributed in space and raise questions about the forces that shape them. What other mysteries do these cosmic threads hold? And how do they fit into the larger story of the universe? The answers might just lie in the next great cosmic enigma waiting to be uncovered. Now, let's turn our attention to one of the most elusive and energetic phenomena in the universe: cosmic rays. These aren't the kind of rays you might imagine from a sci-fi movie, no glowing beams or flashy lights. Instead, cosmic rays are invisible, high-energy particles racing through space at nearly the speed of light. They constantly bombard Earth, streaming in from all directions, and yet, despite their ubiquity, they remain one of the greatest mysteries in astrophysics. So, where do these cosmic rays come from? The answer lies in some of the most violent and energetic events in the cosmos. Supernova, the explosive deaths of massive stars, are thought to be one of the primary sources. When a star collapses and explodes, it sends shockwaves through space, accelerating particles to incredible speeds. These particles become the cosmic rays that eventually reach us. But supernova aren't the only culprits. Black holes, especially those at the centers of galaxies, also play a role. As matter spirals into these cosmic giants, it heats up and releases immense amounts of energy, some of which gets converted into these high-energy particles. Despite knowing their potential origins, tracing the exact sources of cosmic rays is a monumental challenge. Unlike light, which travels in straight lines and can be traced back to its origin, cosmic rays are charged particles. That means they're deflected by magnetic fields as they travel through space, making their paths twist and turn in unpredictable ways. By the time they reach us, it's nearly impossible to point back to where they began. It's like trying to follow a single drop of water in a turbulent river. It's lost in the chaos, but why should we care about these elusive particles? For one, they have a significant impact on our planet and our technology. Cosmic rays can interfere with satellites, disrupt communications, and even affect the electronics on aircraft flying at high altitudes. They've also been linked to genetic mutations, raising questions about their role in the evolution of life on Earth. On the flip side, they've helped us make groundbreaking discoveries. In the early 20th century, cosmic rays were instrumental in the detection of antimatter, opening up entirely new fields of physics. As we continue to unravel the secrets of cosmic rays, another cosmic mystery emerges: neutrinos. These ghostly particles, like cosmic rays, are produced in some of the most extreme environments in the universe. But unlike cosmic rays, neutrinos barely interact with matter, passing through entire planets as if they weren't even there. What makes them so fascinating, and what can they tell us about the cosmos? Let's dive into the enigmatic world of neutrinos next. Imagine a star hurtling through space so fast that it can break free from the gravitational grip of its own galaxy. These cosmic speedsters are known as hypervelocity stars, and they're some of the most fascinating and mysterious objects in the universe. Unlike most stars, which orbit peacefully within their galaxies, hypervelocity stars are racing through the cosmos at millions of miles per hour, often on trajectories that will eventually take them into the void between galaxies. But how do they get moving so fast? The answer lies in some of the most extreme events in the universe. One leading theory suggests that hypervelocity stars are launched by the immense gravitational forces near supermassive black holes. Picture this: a binary star system. Two stars orbiting each other ventures too close to a supermassive black hole at the center of a galaxy. The black hole's gravity pulls one star in, while the other is flung outward at incredible speeds, like a slingshot effect on a cosmic scale. This ejected star becomes a hypervelocity star, racing away from its home galaxy at breakneck speed. Another possibility is that these stars are the result of galactic collisions, where the gravitational chaos of two galaxies merging can send stars flying in all directions. Hypervelocity stars aren't just cosmic curiosities, they're also incredibly important for understanding the dynamics of galaxies. By studying their trajectories, astronomers can learn more about the gravitational forces at play within galaxies and even map the distribution of dark matter. These stars act like cosmic probes, offering clues about the environments they've traveled through and the forces that shaped their incredible journeys. But the mysteries of hypervelocity stars are just one piece of the puzzle when it comes to stars with unusual motion. Up next, we'll explore another type of star that doesn't follow the rules: stellar wanderers with their own peculiar paths through the cosmos. Now, let's turn our attention to a truly enigmatic phenomenon, rogue planets. These are worlds that wander the cosmos untethered, drifting through the vast emptiness of space without a star to call home. Unlike the planets in our solar system, which orbit the sun in predictable paths, rogue planets are cosmic nomads, free floating through the void. But how do such worlds come to exist? Most rogue planets are thought to form in one of two ways. Some are born in the chaos of star-forming regions, where gravitational interactions between young stars can fling newborn planets out into the darkness. Others may start life as part of a star system, only to be ejected later by violent collisions or the gravitational pull of passing stars. Once cast adrift, these planets become nearly invisible, making them incredibly difficult to detect. Without the light of a star to illuminate them, they fade into the background of space, detectable only through subtle gravitational effects or the faint heat they emit. The discovery of rogue planets has profound implications for our understanding of the universe. Astronomers estimate there could be billions, perhaps even trillions, of these wandering worlds scattered throughout the Milky Way alone. This suggests that planets might be far more common than we once thought, hidden in the shadows between stars. Some rogue planets could even host conditions suitable for life, with subsurface oceans kept warm by internal heat or radioactive decay. Imagine a world where life thrives in eternal darkness, far from the warmth of any sun. But rogue planets are just one type of wanderer in the cosmic sea. Beyond these dark, lonely worlds, there are other mysterious objects adrift in space, each with its own story to tell. From interstellar asteroids to mysterious clouds of gas, the universe is filled with travelers that defy our expectations. What else might be out there, drifting silently through the void, waiting to be discovered? The possibilities are as endless as the cosmos itself. Among the most extreme and enigmatic objects in the cosmos are magnetars, the cosmic powerhouses that defy our understanding of physics. These are neutron stars, incredibly dense remnants of massive stars that have exploded in supernova. But with a twist, magnetars possess magnetic fields that are trillions of times stronger than Earth's, making them the most magnetic objects in the known universe. To put that into perspective, if a magnetar were located halfway between the Earth and the Moon, it could erase the data on every credit card on our planet. That's the kind of power we're dealing with, but their magnetic fields aren't just staggeringly strong, they're also the source of some of the most violent and unpredictable behavior in space. Magnetars occasionally experience starquakes, massive tremors in their crust caused by the immense stress of their magnetic fields. These quakes can release energy equivalent to a magnitude 32 earthquake on Earth, a force so unimaginable it's difficult to even comprehend. And then there are the gamma-ray flares, sudden bursts of high-energy radiation that can outshine entire galaxies for a fraction of a second. These flares are so intense that they've been detected from across the universe, even billions of light-years away. Studying magnetars, however, is no easy feat. Their extreme environments push the limits of our scientific tools and theories. For example, their magnetic fields are so intense that they can distort the very fabric of space-time, warping the behavior of light and matter in ways we're still struggling to understand. And because their outbursts are so rare and unpredictable, catching one in action requires a combination of luck and cutting-edge technology. Yet, every time we do, it offers a glimpse into the extremes of nature that challenge our understanding of the universe. While magnetars are undoubtedly fascinating, they're just one type of neutron star with its own unique mysteries. Another intriguing variant is the pulsar, a rapidly spinning neutron star that beams radiation like a cosmic lighthouse. These objects, too, have their own set of secrets waiting to be unraveled. As we continue our journey through the mysteries of space, we find ourselves staring into an immense cosmic emptiness known as the local void. This vast, seemingly barren region of the universe lies relatively close to our own Milky Way, yet it defies our expectations of what space should look like. Stretching across hundreds of millions of light years, the local void is a place where galaxies are few and far between, a stark contrast to the dense clusters and filaments that make up the cosmic web. But why does this void exist, and what does it tell us about the universe's structure? The local void challenges our understanding of how matter is distributed in the cosmos. While we often think of space as being filled with stars, galaxies, and nebulae, voids like this one remind us that the universe is far from uniform. These regions are not just empty patches, they are critical pieces of the puzzle that help us understand the large-scale architecture of the cosmos. The local void, in particular, is thought to play a role in the motion of galaxies, including our own Milky Way, as they are subtly tugged by the gravitational influence of surrounding structures. But studying such an empty region is no easy task. With so few galaxies to observe, astronomers rely on indirect methods to map its boundaries and understand its properties. What little we do know suggests that voids like this one are not just passive gaps but active players in the universe's evolution. They shape the flow of matter, influence the formation of galaxies, and even affect the way light travels across vast distances. Yet, despite their importance, voids remain some of the least understood features of the cosmos. As we ponder the mysteries of the local void, it's impossible not to wonder what other secrets these cosmic empty spaces might hold. And speaking of voids, our next stop takes us to an even more enigmatic region of the universe, one that pushes the boundaries of what we thought possible. But more on that in just a moment. For now, let's take a moment to appreciate the profound questions the local void raises about the nature of space itself. What does it mean for a region of the universe to be so empty, and how does its existence shape the story of everything around us? These are the kinds of questions that keep astronomers gazing into the depths of space, searching for answers in the vast unknown. Among the countless wonders captured by the Hubble Space Telescope, one image stands out as a profound glimpse into the vastness of our universe, the Hubble Deep Field. In 1995, astronomers pointed Hubble at what seemed like an empty patch of sky, no bigger than a grain of sand held at arm's length, but what they discovered was anything but empty. That tiny sliver of darkness revealed thousands of galaxies, each one a swirling island of stars, gas, and dust, stretching back billions of years into the past. This single image transformed our understanding of the cosmos. It showed us that even in the darkest, emptiest corners of the sky, the universe is teeming with galaxies, each with its own story to tell. The Hubble Deep Field became a window into the early universe, revealing galaxies that formed just a few 100 million years after the Big Bang. These ancient structures are like cosmic fossils, offering clues about how galaxies evolved over time and how the universe itself expanded and matured. But the mysteries it uncovered go beyond just the number of galaxies. The Hubble Deep Field also raised questions about the early universe's structure. Why do some galaxies appear so small and faint? How did they form stars so quickly in such a young universe? And what does their distribution tell us about the invisible scaffolding of dark matter that holds the cosmos together? These questions have kept astronomers busy for decades, and they're still far from fully answered. The Hubble Deep Field wasn't just a scientific breakthrough, it was a profound reminder of our place in the universe. It showed us that even the most seemingly insignificant patch of sky can hold countless worlds, each one a testament to the vastness and complexity of the cosmos. And this wasn't the end of the story. Later deep field observations like the Hubble Ultra Deep Field and the E-Extreme Deep Field have pushed the boundaries even further, revealing galaxies so distant that their light has traveled nearly 13 billion years to reach us. Each of these images is a treasure trove of cosmic secrets, waiting to be unlocked by the next generation of telescopes and curious minds. Imagine the universe as an unimaginably vast spiderweb stretching across billions of light years with galaxies clinging to its delicate threads. This is the cosmic web, the grand architectural framework of our universe. It's not just a random scattering of stars and galaxies. It's a carefully woven network of dark matter and gas, invisible to the naked eye but holding the cosmos together like an invisible hand. This intricate structure guides the formation of galaxies, funneling matter into dense knots where stars are born and galaxies grow. But mapping this cosmic web is no simple task. Dark matter, which makes up most of the web, doesn't emit light or interact with electromagnetic forces, making it nearly impossible to observe directly. Instead, scientists rely on its gravitational effects, studying how it bends light from distant galaxies or influences the motion of stars. Even then, the sheer scale of the web, spanning billions of light years, makes it a monumental challenge to chart. Every discovery feels like uncovering a single thread in an endless tapestry, revealing just how much we still have to learn about the universe's largest structures. And yet, the cosmic web isn't the only mysterious structure shaping the cosmos. Just as this vast network influences the birth of galaxies, other enigmatic formations play their part in the cosmic dance. One such structure, equally fascinating, is the Great Wall of Galaxies, a colossal filament of galaxies stretching across the universe, defying our understanding of how such immense formations could exist. But that's a story for another moment. For now, the cosmic web reminds us that even in the vast emptiness of space, everything is connected, bound by threads we're only beginning to see. Now let's travel back in time, way back to the very dawn of the universe. Just moments after the Big Bang, the cosmos was a swirling sea of hydrogen and helium, a cosmic soup without structure. But then, something incredible happened. The first stars were born. These weren't just any stars, they were the pioneers of the universe, known as population Roman 3 stars. Unlike the stars we see today, these ancient giants were made almost entirely of hydrogen and helium, the simplest elements in existence. They were massive, burning hot, and lived fast, lighting up the darkness of the early universe. But here's the thing, they're gone now. Not a single one remains, yet their legacy is written across the cosmos. These stars played a crucial role in shaping the universe as we know it. When they died in spectacular supernova, they seeded the cosmos with heavier elements like carbon, oxygen, and iron, elements that would later form planets, life, and even us. Without population Roman 3 stars, the universe would be a very different place, but detecting them is no easy task. Since they existed over 13 billion years ago, their light has faded into the cosmic background, leaving only faint clues for astronomers to piece together. Scientists use powerful telescopes and computer simulations to hunt for their fingerprints, searching for the faint echoes of these ancient giants in the farthest reaches of space. The mystery of population Roman 3 stars isn't just about finding them, it's about understanding how they shaped the universe's infancy. They were the architects of the cosmos, the first to turn chaos into structure. And while we may never see one directly, their story is woven into the fabric of everything around us. But the early universe holds more secrets, and the story of its beginnings is far from complete. Up next, we'll explore another cosmic mystery tied to the universe's infancy, one that might just reveal how the first structures in the cosmos came to be. Stay with us, because the journey through these ancient mysteries is just getting started. What if everything we know, our universe, our galaxy, even our own existence, is just one tiny piece of an unimaginably vast puzzle? This brings us to the 34th mystery, the mind-bending concept of the multiverse. At its core, the multiverse theory suggests that our universe isn't the only one out there. Instead, it's just one of countless others, each potentially governed by its own unique set of physical laws. It's a staggering idea that challenges everything we think we know about reality itself. So, where does this theory come from? One major piece of evidence lies in quantum mechanics, the study of the smallest particles in existence. In the quantum world, particles behave in strange, unpredictable ways, and some interpretations suggest that every possible outcome of a quantum event actually happens, just in different universes. Imagine flipping a coin. In one universe, it lands on heads. In another, it's tails. Now, scale that up to every decision, every event across all of time. The implications are staggering, but quantum mechanics isn't the only clue. Cosmic inflation, the rapid expansion of the universe just after the Big Bang, also plays a role. Some scientists theorize that this expansion didn't just create our universe, it could have spawned countless others, each with its own unique properties. Picture bubbles forming in a pot of boiling water, each bubble representing a separate universe floating in an endless cosmic foam. Of course, the multiverse isn't just a scientific curiosity, it's a philosophical minefield. If there are infinite universes, does that mean there's a version of you living every possible life? Could there be a universe where dinosaurs never went extinct or where Earth never formed at all? These questions don't just stretch our understanding of science, they challenge our sense of identity and purpose. As we stand on the edge of this cosmic mystery, it's impossible not to wonder what it all means. And while the multiverse might feel like the ultimate frontier, it's not the end of our journey. In fact, it leads us to one final, even more profound mystery, one that ties together everything we've explored so far. But we'll save that for the grand finale. For now, let the idea of the multiverse sink in and ask yourself, what kind of universe do we live in and what might be out there waiting to be discovered? As we wrap up our journey through some of the most baffling enigmas floating in the vast expanse of space, one thing becomes crystal clear. The universe is far stranger and more mysterious than we could ever imagine. From the eerie whispers of unexplained radio signals like the WOW, signal to the mind-bending oddities of rogue planets and dark matter, each mystery we've explored today challenges everything we think we know about the cosmos. These aren't just anomalies, they're cosmic puzzles that push the boundaries of science and ignite our collective imagination. Take, for instance, the bizarre behavior of Tabby's star, dimming and brightening in ways that defy explanation, or the perplexing Oumuamua, an interstellar visitor whose shape and motion left astronomers scratching their heads. These phenomena remind us that space is full of surprises, and every discovery raises even more questions. What are these signals trying to tell us? What unseen forces are at work in the void? And could there be something or someone out there waiting to be found? These mysteries don't just challenge our understanding, they inspire us to dig deeper, to keep searching for answers. They remind us that curiosity is the engine of discovery, and that every question we ask brings us closer to unraveling the secrets of the universe. Science is a never-ending journey, and the cosmos is the ultimate frontier, filled with endless wonders waiting to be uncovered. So, as we gaze up at the night sky, let's remember that the universe is not just a place of stars and planets, it's a canvas of infinite possibilities. It's a reminder that there's so much more to learn, to explore, and to dream about. As Carl Sagan once said, somewhere, something incredible is waiting to be known. And it's up to us to keep looking, to keep questioning, and to keep reaching for the stars. What do you think about these cosmic mysteries? Have any theories or thoughts about what might be out there? Share your ideas in the comments below. We'd love to hear your perspective. And if you're as fascinated by the wonders of space as we are, Don't forget to subscribe and join us on this ongoing adventure into the unknown. The universe is vast and the mysteries are endless, so let's keep exploring together.